Hello community, what a beautiful Monday morning, and I was asked by my subscriber, hey, can you explain the new RAG, this new solution by Anthropic that is called Contextual Retrieval. But yes, of course, but have a look here, why is it better than the good old RAG? Now, I was asked by one viewer, hey, please only use here the official Anthropic documentation. Do not do your thing, whatever this should mean. So, okay, I just make screenshot here from anthropic.com news contextual retrieval. This is here only the official documentation. It's a little bit more challenging, but no problem at all, and understand some might not really immediately understand here this presentation by Anthropic. So here we go. The introduction, they say, hey, the simplest solution is the best. So they say, if your knowledge base, if your document server, whatever you want to extract is smaller than 200,000 tokens, and what a coincidence here, Anthropic's models have 200k context length if we count it in tokens. This is about 500 pages here. You can just include the entire documents in the prompt. And there's no need for RAG or similar methods. So Anthropic tells us, hey, if you have less than 500 pages that you want to have integrated here as your knowledge base for the prompt for your LLM, like by Anthropic, do not use RAG. Okay, we follow Anthropic. Great. And they say, okay, but if you have to use here the old RAG, you know what we do. We break down the knowledge base, this is the corpus of the documents, into smaller chunks of text. Normally about 100 token, 200 token, whatever, maybe just 50 token. And then we use an embedding model to convert those textual chunks into a new representation, and we choose here a vector representation, and we do here a vector embedding that should encode here semantic similarity in the meaning of the textual string. And then we store those vector embeddings in a vector database, and you are allowed to pay for vector databases, or you use an open source vector database. Great. And at runtime, when the user inputs here a query here to Anthropic here, the vector database is used to find here the most relevant chunks based on the semantic similarity, like a cosine similarity to the query, and then the most relevant chunks are added to the prompt that are then sent to our Anthropic model. This is the classical RAG system. And now Anthropic tells us, hey, yeah, beautiful. While these embeddings model excel at capturing the semantic relationship, they miss crucial exact matches. So if you look here, for example, if you have a CTO or a CFO, you look here for a technical term or for some financial data, well, it's not gonna work really perfect, but we have a solution. There's an older technique here from the Stone Age of search engines, and this is our best match 25. BM25 is the workhorse, is perfect, is here additionally used here as a ranking function that uses here the lexical matching to find the precise word or the precise phrase matches. Great. So we just add this here in our classical RAG system if you want to have an acceptable RAG performance. So here we have it. We have here the classical RAG if you want, and then we have best matching 25, our real perfect workhorse for exact word or phrase matches. And now Anthropic tells us here, please, I'm still here with the official Anthropic documentation, a significant problem emerges here, even in this combination. And Anthropic here tells us here the context conundrum in traditional RAG. These documents that are split into the smaller chunks here for this beautiful efficient retrieval in the vector stores, this approach works well for many applications. It can lead to problems when those chunks, they simply lack sufficient context. And then RAG is not working anymore. And you might say, how is this possible? And they give us here a beautiful example in the official documentation by Anthropic. And they say, imagine you have here some collection of financial information, SAC filings, whatever in your knowledge database. And you say, hey, when was the revenue growth for a particular corporation here in the second quarter of 2023? Now, it could happen that those chunks that are stored in your vector store or in your vector database or whatever commercial vector store you bought contains the relevant text. The company's revenue grew by 3% over the previous quarters. However, now this is here the interesting part, this chunk on its own does not specify which company it is referring to. It is just the company or the relevant time period. So what the hell does this chunk relate to? So what happens now, and this is here for my green grasshoppers, yes, I put in now some of my stuff. I just want to make it easier to understand. Imagine we have a vector store, a vector space, and the easiest you can think of is a two-dimensional. You know, in reality, we operate with multiple thousand-dimensional spaces. And in this simple vector space, we now find a vector representation and embedding. Company A is here, company B is here, and company C is located here. Beautiful. We have now a vector embedding of semantic information of this company. But now let's take this as this official example by Anthropic here. The company revenue grew by 3% over the previous quarter. In building now the vector space, the system found, hey, this is great. I have this sentence here. And it said, hey, the system says also, hey, I have a sentence that is almost identical. Look, the company's revenue grew by 7% over the previous quarter. And this is here 3%. So now in building the vector space, the system aggregates similar semantic meaning and strings. So it puts those two sentences real close together. And here is what Anthropic in the official documentation says. It has no connex anymore to what of those companies, of these three companies, those two indications relate to. So, because if we look now what is close by, like a cosine similarity in its easiest case, or if you have an epsilon environment here in a particular vector store and we look for real similar semantic constructs in the embedded space, we see, hey, those two are real close together, but we have no context to what object it belongs to. So this is what we call a dysfunctional RAG system. Isn't this beautiful? May I remind you, this is an oversimplification by me, because you have to take care about your tokenizer, what you tokenize, how the context is tokenized. You have to take care about your base text for the tokenizer to building here a vector representation for RAG. Because if you have a base text that is only concerned about, I don't know, little chickens that hardly can fly, and you have 10 million documents about chicken only, and then my question would be about the American eagle flying here from continent to continent, you understand immediately, oh wow, we are in some deep trouble. Also, both are birds. Then, of course, the chunking. How you chunk up these documents and present what kind of segments to your embedder. Well, this is, you better get the chunking size right. And maybe you need some flexible chunking. And then how you build your vector space, with what algorithm, on what domain-specific data, on what multi-domain specific data, how you aggregate multiple domains in your high-dimensional vector space. Those are all things that are not trivial, and yes, you can buy commercial vector spaces. But maybe your question, your task, was not learned in this vector space. So you see, there are so many open questions that we will encounter, but hey, I told you today it's about solution only. So I was asked by my subscriber to explain here Anthropic solution. So now I explained the problem to you, and now second part of this video, we go here to this beautiful solution just about, some 2 weeks ago. And let's have a look what's happening and what is the solution. So Anthropic introduced here contextual retrieval. So the retrieval from RAG, retrieval, augment, and generate. Now we are here at the contextual retrieval. And it tells us, hey, this retrieval solves the problem by prepending here chunk-specific explanatory context to each chunk before we do here the vector embedding, before we build here the index for our BM25. And we have now what we call contextual embeddings. So yes, we build a complete new vector space. And of course, we have a complete new BM25, also a complete new contextual BM25 index. Isn't this beautiful? So depending on the size of your documents, hey, you are in for some beautiful surprises. And in the official documentation by Anthropic, it's stated here, example of how the chunk might be transferred. So we have here a chunk, and this is okay, just one sentence, no problem. The company's revenue grew by 3% over the previous quarter, and you see I stick absolutely with the examples by Anthropic. And now the new improved, if you want, RAG 2.0 or RAG 17.0 contextualized chunk is, now we have the information, what is the company. So this chunk is from a SEC filing on this specific corporation performance in the second quarter of 2023. The previous quarter revenue was so and so much millions, and the company revenue grew. And now you see, now we have the original chunk, but before the original chunk, we have all the contextual information. And now you understand why we have a contextual chunk. And you might say, wait a minute, so for all on every chunk in my corporate document server, I have maybe millions of documents. Who is doing this work? Well, you are lucky, because Anthropic tells us here, a little hint for my next video, it would be far too much work to manually annotate here thousands or millions of chunks in a knowledge base. So you can pay Anthropic here, and a Claude model like Sonnet or Haiku or whatever will do the work for you. And they have written a prompt that instructs the model to provide here now a concise, chunk-specific context to explain the chunk using here the context of the overall document. So this is now, think about this, an exercise. So for each chunk, so let's say for each, they give us here the example of one sentence in a document. Claude, any Claude model you have to pay for is taking now here the first sentence and put it in relation to the complete document. Then it takes the second sentence, puts it into relation to the complete document, and writes here an augmented contextualized prompt. So you see how the new RAG system is developing. So how we do this? Well, it is rather simple. They give us here a document, the whole document, and then we say, okay, for each and every chunk, and we have here already chunked up our document. So for chunk number 1, please, we talk now to, 3.5 Sonnet, please give a short, succinct context to situate this chunk within the overall document for the purpose of improving here the search retrieval of the chunk. Answer only with the very short new context and nothing else. So you see, this is now a new task to an AI model, to Sonnet, to Opus, whatever you have. This is now quite some work for the AI model, no? And you know that, let's say, model hallucinate more or less depending on your domain-specific content, depending on what model you choose, how much you pay, maybe not for the best model. If every single sentence, like in the example by Anthropic, is now analyzed and added with information by an AI model, let's say, Haiku, if Haiku gets it wrong, only 1 in a 10,000, oh yeah, you're in for some treat. Yeah, if we look here, of course, I had a look at the original code, and you see it is really that easy. You have here now a contextual vector database where you have here a simple function to situate the content. So you have the context prompt. Here's the chunk that we want to situate within the whole document. And then here you have really the command, here, please give here a very short context to situate this chunk within the overall document for the purpose of improving here the contextual relevance, answer only with the succinct content and nothing else. And they use here Haiku, yeah, the cheapest model, of course. Then you define here the maximum token length. Be careful. If you are here too short, you will have some real problem later on. So yeah, you have to invest here a little bit more money. And this is it. And then you just load the data. Yes, beautiful. And you do here the processing. Yes, great. And then you embed here this new this new information in new embeddings in a new vector space, in a new vector store. So yeah, there are some additional costs associated with this. And you see this, if you set up this system, and this is here the original code by Anthropic, you have to pay for Anthropic to interact with Claude, then you have to generate these new embeddings, so they go here with one possible way. Then you have, and I will show you in a minute, to do some re-ranking, so you pay here a third company, and then to perform BM25 search, yeah, either you go here with Elasticsearch or any other company application that you like, and then you go hopefully with some open source Panda NumPy scikit-learn application. So you pay 4 or 5 companies if you really want to have here. To follow this model, you pay here those 3 companies. Yeah, I'll stay here with the official Anthropic documentation. Great. So you see, you should think about the implementation maybe in a complete open source way. And then here, Anthropic tells us the resulting contextual text, usually 50 to 100 token, is prepended to the chunk before embedding it and before creating now this new BM25 index. And at this moment, you might say, heaven's sake, so this means that for every 50 tokens, or every 100 token, in my complete corporate documentation server, I chunk it up in, let's say, 50, 100 token, and then for each and every single optimized new, if you want, contextualized word, I have to call the complete document to my Claude model, and I have to pay Claude here for every token input and output. This would either make Anthropic every staff there a billionaire within a week, or you might discover that paying thousands of dollars is not really what makes Anthropic competitive. And we are talking about solution, no? So here the official documentation, contextual retrieval, pre-processing by Anthropic. This is officially here. So you have your corpus, and then you have your documents, and then you chunk up the documents in chunk 1, chunk 2, chunk 10,000, or whatever you have. And then you run the prompt for every chunk to situate it within the document. And there you have this innocent little looking blue line. But this is wrong, because this little blue line should go here above chunk 1. Because this is not that this is an input at a later place. No, you take chunk 1 and the complete document. You take chunk 2 and the complete document. You take chunk 10,000 and the complete document. And now we come to the second main element. 2 weeks ago, Anthropic introduced for us prompt caching. And people were not sure about, because the marketing department of Anthropic just said, hey, it makes so much cheaper. And you say, yeah, but only if I have thousands and thousands of identical queries. Now with this, 2 weeks later, we immediately understand why prompt caching was invented or given to us as simple user here by Anthropic, because this new RAG system would make it here from the price point impossible that Anthropic would be able to provide you this new product. So this now explains why we get 2 weeks ago the prompt caching functionality on Anthropic. You know, sometimes it takes a week or 2, but then we understand why things happen here in the corporate profit maximization. Great. Yeah, and then if we have done this and calculated this for every 50 to 100 token, we have then the new context 1 that is generated by, let's say, I don't know, 3.5 Sonnet. And then we have chunk 1, and then we have the new context as generated by 3.5 Sonnet and the chunk 2. And then we have the new 10,000 context as generated by 3.5 Sonnet plus the chunk X. So we have now complete new structures, and now we have to build up a complete new embedding model, a complete new vector space, a complete new vector database. And yeah, other companies too can make money with this new idea. I mean, isn't this beautiful? America, I am loving here this profit optimization for global cooperation. Okay. Yes, of course, as we know here from the marketing department here, contextual retrieval is uniquely possible at low cost with Claude, thanks here to the special prompt caching feature. Because without this special prompt caching feature, you would really be surprised when you see your next bill. So let's talk here about the results. And here the official marketing documentation by Anthropic tells us here the contextual embeddings. Now these new embeddings reduce here the top 20 chunk retrieval failure rate by 35%. Now this is a relative indicator. Let's look at the absolute indicator. So Anthropic, my goodness, claims that the failure rate here for this new RAG goes from 6% to, let's say, 4%. Now, let me tell you a little bit later. And then combining here the contextual new embeddings and now the new contextual BM25, the CBM25, if you do this now together, like in the old RAG system, we can further reduce here the top 20 chunk retrieval failure rate from 6% to 3%. Now I have to tell you, I also, if I have to use RAG, okay, I have more than 10,000 documents here, only scientific, only theoretical physics, mathematics, and chemistry. And if I would do a top 20 chunk retrieval failure rate, my absolute error would be above 30%, 3-0. If I can do here further, yes, you know, I try here to come close to 20%, where here in this marketing example, Anthropic is at 3%. So, yes, so my personal experience tells me that there is a multiplicative factor of 10, where my experience is not at all in this, but hey, Anthropic is, of course, they are much more intelligent, much more clever, much more, better people there. So I think this is because, yes, I can't be as beautiful as they are. However, if you read here a little bit further on, you see, especially if we do then the third step of the optimization, this is the ReRanking. So we now, and this is here, okay, because I do here, if I do the ReRanking, I do a ReRanking. Officially in the commercial software, it is recommended you go with 1,000 top chunks. I go with 2,000 top Ks. Here in the marketing material by Anthropic, it is the 150 top chunks are retrieved here for the ReRanking optimization. ReRanking simply means you retrieve for one query 2,000 answer by the RAG system, and then you have another complete analysis cycle, and you reduce this 2,000, let's say, to 200, and then you have another completely ReRanking system, and then you are from 2,000 to 200, and from 200 to 20, and from 20, then 20 is what an LLM like here 3.5 Sonnet should handle. So again, here I am a factor multiplicative 10 higher in my real world experience, but of course, I'm definitely here working only in science. So this is not for a real world average Bob, John, May, Doe person. So, okay, you get the message. What is nice by Anthropic is they give you here a few considerations. If you want to be successful with this new methodology, they say, hey, careful. Because maybe this marketing department was giving you here the very shiny, the beautiful view of the world. So they say, careful. Chunk boundaries, this is important. Consider how you split your documents into chunks. The size of the chunk boundary, and the chunk overlap can, may I say, significantly affect the retrieval performance. So if you got for your domain-specific knowledge in your domain-specific document server, and your domain-specific document will have a specific length, and you chunk up then each and every document, hopefully with a flexible chunk boundary, respecting here the contextual content of your documents, be careful, the chunk boundaries are really, really important. Second, you have to build the vector space. How you do this embedding model is also really important. And they say they go here with the commercial vector spaces that you can buy, of course, because they want here in the American way to increase the profit. And they tell us here very clearly, hey, Gemini, Google, and Voyage embeddings here are particularly effective for their particular implementation. Second, they say custom contextualizer prompts. They say, while the generic prompt we provide works well, you might be able to achieve better results with prompts tailored to your specific domain. Mine would be science or theoretical physics or mathematics or chemistry. For example, they say, include a glossary of key terms that might only be defined in other documents in the knowledge base. So what they tell you is you have your query, then you have your contextualized prompts by this new Anthropic methodology, and plus include here now a list of very specific terms, like quantum chromodynamics in my case, kind of a glossary that the BM25 has it easier to absolutely identify the overall topic, the overall theme, and then go down with your glossary key terms that you add to your prompt. Interesting that this is still necessary here, almost in October 2024, but okay. And then they give you a warning, and I think this is great, this is correct. Adding more chunks into the context window increases the chances that you include now the relevant information that you ask for in your prompt, in your query. But now that in our prompt here, that we feed in then to 3.5 Sonnet, we have so many chunks, and now not only the chunks, but now also these contextualized chunks. And these contextualized chunks plus some glossary key terms for the topic identification, there is then maybe an overload of information, maybe also with some irrelevant information. And now the question is, how many chunks should you fill up here for Anthropic? And the Anthropic system or the models, have a maximum context length of 200K token length. How many chunks should you put in? And I think they give you the answer. For them, they found in their examples, in their domain, with their vector embeddings, it is about 20 chunks. So interesting to see this. Now, if you've seen my last videos here by Google, and I showed you here Michelangelo, if you have a 1 million token reasoning and you want to break it down here, Michelangelo is exactly the idea by Google. Google tells us here, hey, in this 1 million token reasoning, we have to get rid of all the information that is not contributing to the solution. So in this 1 million token string, maybe only, 1,000 tokens are containing the real information for a specific task that we can answer this specific task. So the challenge is to get rid of information we don't need. And you say, okay, this is just Google, but in my last video where I showed you here by Stanford University and Tsinghua University, this is also happening in the very latest models just published days ago. If they go for new AI agents for advanced reasoning capabilities. If you have a look at this video, you understand that also there it is. We have to reduce the information that is not absolutely essential to answer the user query. We have to get rid of it. Don't put it in the prompt. You pollute the prompt. So there is an interesting balance that is depending on your domain, on your complexity, how you build your vector space, the tokenizer you use, and to have a good performance. So whenever you hear or see some results, please notice, be careful, because maybe those results are, how to formulate this in a friendly way, are from the marketing department of the global corporation, and maybe they want to sell you their product. Great. Now, talking about the results, this here is now the end here also from the official Anthropic documentation, as you can see in the first line. And they tell you now the result. And this is an image with 5 rows here, and I've cut out 3 rows. So please, some additional data were cut out. I just want to show you 2 rows, but in the original paper, for legal reasons, there were 5 rows. Just want to give you the result. So if they say we go for fiction, what is the failure rate? Or if we go here for archive, for science paper, what is the failure rate? And they go here with the Voyage embeddings, they go here with the Cohere embedding, and they go here with the Gemini embedding, the 1 and the 4 version. And independent, look at this. Independent where you are, if you just go with the RAG embedding, the old one, you have a failure rate of 13%, or of 19%, or 18%, or 7%. If we add the embedding with the good old workhorse BM25, or search engine, this failure rate almost halves, yeah? 7%, 6%, 8%, great, all over the place. If we then do the re-ranked embeddings, plus the classical BM25, you see the performance goes from 7.8 to 5%. So those re-ranking here is improving here, but you see the jump is not as big as here the first jump if you go for the exact phrase identification with BM25. But now let's say you're at 5% or 4.8% or 5.3% or 5.9% or 5.5%. I guess you understand in which bandwidth we are operating here. And then comes now the new beautiful contextual embedding here by Anthropic, the product they want to sell you. And now you see we start not at 13%, now at 7%. And now, if we do now contextual embedding plus the new contextualized BM25, we really go down to, let's say, 3%, and then close to 1% if we do a re-ranked contextual embedding and a C BM25. Now it is interesting that here, independent here of our embedding structure, this is close to 1%, 1%, 1%, 1%, 1%, 1%. So the marketing tells us here, in trying to sell this product, with this new RAG X point Y, you can achieve only a 1% failure rate. Should you trust those data from the marketing department? Interesting. We have some demo code here on GitHub, as I've shown you. Yeah, maybe I show you. So we have here the official documentation, as I was asked for by Anthropic to explain this. And then you have here also the cookbook, and here you have the contextual embedding, and here you have also, for a specific demo, some specific code. Now, the question is, 1% failure rate would be a dream result. But is it realistic, or is this just here from the marketing department here an indication how good it could be theoretically in the best of all worlds if we have a very, I would now say from my point of view, a very simple system? I hope all that my subscriber that I was asked multiple times to explain here this new RAG, this new improved RAG, this so much better RAG. What is it? How is it working? Why there is something here with this prompt catching, with this memorization here? How does it connect, and how much better is it compared to the normal models? If we go here with Anthropic, you can see here for a Gemini example, we go here from the best available classical RAG system of 5% failure rate down to a failure rate of 1.2%. This is it for today. It would be great to see you in my next video.